Welcome to the last community call of the year. We are super excited that you have all joined us, and we have an absolute ton of updates for you all today. I'm super excited about it. Let's have a quick look at the agenda today. So we have a product look back over the last year. That's going to be really eye-opening and just enjoyable moment for everybody. We are going to look at the Snowflake integration, which, I mean, that's on brand. So I'm excited about that. We're going to have a look at AlloyDB and the integrations there. We're going to be looking at parameterized queries, which is actually a really, really cool feature I'm personally excited about. Improvements to actions. I mean, these are actually really sweet. So that's a great one too. And then we have elastic connection pooling, which is going to really help out a lot of you, and then dynamic DB connections as well. So people who have a lot more database requirements on how you connect, really awesome stuff there. And then we have our community contributor today. Super excited to have the OG community champion, Gordon, today to give us his contributions to working with and helping shape the streaming subscriptions and the latest updates we had there. So really great stuff. That being said, I'm going to hand it straight over to Tanmai, who's going to give us the product look back. So it's all you.
It's great to see you for the last community call of the year. What I was thinking of doing was, when I was thinking of product look back, I thought what I'd do is kind of summarize how we're kind of taking all of the work that we did doing over the last few years, and kind of formalizing that and gearing up for a set of kind of additions that we're doing next year. Now, some of you might have already seen this with what we call the GraphQL data specification and kind of the soft preview that I did a few weeks ago. So I'm just going to spend maybe a few minutes talking about that and kind of what kinds of things it leads to, just so that you folks have kind of an understanding of how we're thinking about things and how those things are evolving, etc. So with that, let me just quickly share my screen. If you head over to Hasura/GraphQL data specification, you'll be able to see this repo as well. It's still very early draft stages, but what I'll do is I'll kind of talk through this a little bit. So over the last few years, as we've kind of been building the GraphQL API, been adding authorization features, we've been adding new features and subscriptions and stuff like that, right? One of the things that, especially if you're a user of Hasura, is you notice kind of the effort that we put into making sure that the overall API design that's kind of coming out through Hasura is as kind of coherent as possible, right? It feels like it feels almost like a language on top of GraphQL that helps you navigate your data graph and fetch things from the underlying data source and stuff like that. And you'll see that concepts compose really well too, right? For example, you have aggregations, but aggregations also work with relationships, right? You'll have permissions that work in, whether you apply those permission rules at the top level or whether you apply them inside relationships. You'll see kind of those things working as well. And over the last year, especially, we've been kind of bringing that to multiple data sources. We're talking about Snowflake, for example, today. And then over the coming months, for example, we'll start bringing those kinds of things to increasingly to actions and remote schemas and stuff like that as well, right? So when we're kind of doing this, right, one of the things that we realized was it started becoming really important for us, especially, was to kind of talk about like what the formal foundation for us was in articulating kind of what the GraphQL data API is, right? And so what we did is we started putting together what we call the GraphQL data specification that kind of describes the underlying grammar and the query language of what the GraphQL API that is built on Hasura can do, right? And everything from kind of aggregation functions to predicate functions to how relationships work and stuff like that, but kind of a specification of how Hasura is generating that API and what the API is like, right? A key part of this is the authorization system. And so we're calling that system a system similar to RLS, that systems that Postgres and Oracle have. So we've called it node level security because it traverses the graph. And node level security now also has a formal foundation for what this authorization system can kind of be like, right? So you can check that out by there's a small playground put together. And so if you check out the playground, you'll also be able to kind of play around with the specification. You'll be able to play around with the GraphQL data API that's being generated and stuff like that. And so you can kind of try that. Now, why is this foundation important, and how does this help? How does this help us build Hasura together, and then how does it also help you folks using Hasura kind of get more features on Hasura, right? And so I'll take a few examples of how this works, right? Let's say, for example, we're talking about like our authorization system, right? Now, there are a bunch of feature requests and enhancements and extensions that we kind of want to make to the authorization system, right? Let's take a few complicated examples that we want to have on the authorization system. The first, for example, is that we want to be able to have our authorization, the permission syntax, extend to remote relationships as well. If we allow you to kind of create RLS rules that use remote relationships, that then allows you to use entitlements or access control lists from other databases and apply that to kind of the data source where your data lives, right? You can even use that as we kind of add support for more data sources. You can imagine a world one day where we have Vault as a data source, and you're actually able to use Vault inside your permission syntax as well, right? And the system can you can increase the amount of work that you can replace with that authorization system now. But kind of starting to do that means that the amount of complexity that we're increasing is quite high. And to preserve the elegance and the simplicity of how Hasura helps you do things becomes really important for us to have that technical foundation. So node level security as a technical foundation, as a formal specification kind of helps us build those features and consume those features and have tooling around those features easily. Take another example of the kind of extensions that we're thinking about to node level security, right? And again, none of these are, this is not, this is the hard stuff that we kind of all want from the system, right? So for example, the ability to apply functions when we're making authorization checks as well, right? So whether you have SQL functions, whether these could even be actions that you have, right? But you want to be able to say that I have an email type that's kind of being in a mutation, that's showing up in the mutation, and you want to be able to apply validation to it, right? So you want to be able to say, I have an is email SQL function, or I have an is email action, and you want to be able to apply that in the authorization rule so that you can handle more complicated cases around validation. You want to handle more complicated cases around authorization as well, where this function that is evaluating a property is external, right? It's not a part of the predicate system that the database has or that Hasura provides. So these kinds of extensions that we make to our authorization system over next year are going to kind of come from this underlying formalization of node level security. So that's kind of that's kind of what node level security lets us do, right? When we talk about the GraphQL data specification or the GraphQL API itself and how we think about the GraphQL features that we want to add to Hasura and the modeling features that we want to add to Hasura, right? We'll be talking about parameterized queries, for example, and today, which is a very powerful way to improve our mapping, especially for existing databases and bringing that into Hasura, right? But these kinds of features are more advanced aggregations, thinking about adding group by and having, and it's not challenging to build those things. But what is interesting is that when we build those things, the GraphQL API design must be really nice and easy, right? It must compose the way features today compose in Hasura. And what this lets us do now is really kind of define a formal specification for how those aggregation APIs will show up. So all of that is kind of going to start coming through what we're calling the GraphQL data specification, and a bunch of enhancements that we think about, the designs that we think about will come through this open specification. We're also going to be working with some folks in the community and some vendors. We're also looking at GraphQL on data use cases. So if any of you are working, any of you are part of a larger organization where you're part of a platform team, where you're thinking about GraphQL as a data layer, feel free to reach out and start kind of collaborating with us on this specification, because this will kind of solve for the API design, the authorization design that you want to have in your centralized kind of API layer, right? And so we're starting to work together with some folks in the community who have the GraphQL data API layer that they want to build and that they're building, and some vendors who are also providing kind of these data APIs with GraphQL on their data sources. So that's kind of some of the work that's happening here. I did preview this in the Enterprise GraphQL Conf talk. So if you head to the repo, you should be able to check out the talk as well. And that should have a link to the slides as well, which kind of talks about this in a little more detail, and kind of some of helps those of you who are curious understand visualizing kind of what the technical foundation is, right? Like how we are modeling things in a data graph and how we're creating the GraphQL API across a single source or across multiple sources. So do check that out, and this will help. This will help inform all the work that we're doing here. So that's kind of what I want to talk about, and that's where most of that. This is kind of a good summary of the work that we've been doing so far, and a great guideline for us as we kind of build and add more features, making sure that Hasura kind of stays a simple and a coherent product for people as we scale with complexity. That's me. I'll hand it back to you.
Thanks, Timai. And that really is just a fantastic specification. The talk is excellent. And what I really like about it is how it's really just looking at what GraphQL has evolved into over the last many years at this point, and sort of kind of looking into what does it need for proper growth going forward? What kind of structure does it need to really be all that it can be? And especially Hasura, where we look at, the GraphQL meeting the data connectors, ultimately it's really a powerful piece. So highly recommend. So super exciting stuff. With that being said, we're going to hand it over for our Snowflake integration preview with Adrian. Thank you so much for being by today. And I know that it was a bit of an unfortunate timing for you to be live with us, but we really are glad that you were able to make it. So why don't you show us what you got with Snowflake?
So just for a quick recap, I know many of you may be familiar with Snowflake, but just to know what it is, Snowflake, they refer to themselves as the data cloud. It's a place where you can kind of break down all your different data silos and pull all your data into a singular place where it's online in the cloud, distributed horizontally, et cetera. And then you can run your reports and your analysis and all of this against their particular data cloud. And it's provided via two primary sources, which is their data warehouse option and their data lake. So a lot of different options in there. Also, I'm very much paraphrasing it. It's a very extensive platform. So Hasura has just released a driver for Snowflake. Right now, the way you access Snowflake is through SQL. And if you want to do something with GraphQL, traditionally you would have to kind of just hand roll your own solution, which could be very cumbersome. With the new connector, though, you can get into Hasura, and I've created a project here just to show you exactly what I'm talking about. And I'm going to launch that and bring it up, and we're going to connect to a Snowflake instance and actually run some queries against it, and thus enable GraphQL with Hasura against Snowflake. So like with any data source, you want to connect it through the data tab where you manage your databases. And in here, you would find that under the Snowflake beta option. There is one extra little step right now while it's in beta where you'd have to go over to your config button, go to feature flags, and make sure that this feature is turned on. So that's the only initial step, but otherwise everything else is exactly the same. And it will show here if it is one of the connectors that is available at that point. So I'm going to hit connect databases, pick Snowflake, and then I'm going to paste my JDBC connection string into the database URL here. And then I'm going to name this Snowflake example. Hit connect database, and in a few seconds, as soon as it verifies the authentication and makes that connection, we'll be connected to our particular instance. Now, the first thing you do once you get to this point, you've made the connection, you're authenticated to your Snowflake instance, but then we need to pick our particular tables that we want to expose via the API. Right now, we know these tables are in here. Hasura has looked at these and introspected against them, but we haven't exposed anything at this point. So for this, I'm just going to pick two. I'm going to go with album and artist just for this example. One of the very powerful things here is when you're in your Snowflake instance, a lot of instances may have like 1,000 tables, and you really just want to pick the ones that you want to query against, like keep your API nice and clean and everything. So I'm going to select those two. And then over here, you'll see that you can now drill down into this and see the tables that you have exposed. And at this point, if I bounce over to the API, I can run a query and, for example, get a list of the artists that I have in my Snowflake database. So pretty straightforward list there. Some familiar artists that some of you may know. Now, this is nice. This is just a straightforward query. We also have capabilities built in already where you can get aggregates of things. Like, for example, I want to know how many artists do I have in my database, right? So let's do that. Pick the column and we'll just go by artist ID. That'll give me a good count. And there we go. Get an aggregate roll-up of 275 artists within the database. So that's cool. But let's say you want to actually know about albums. Right now, I don't have a connection so that artist knows that it has albums in this particular data set. So what I can do is go back over to data and go into Snowflake here. And I'm going to go to artist and I'm going to create a relationship. Create a relationship and I'll call it artist albums. And since I know that an artist has multiple albums, I'm going to pick the array relationship so that I will get an array back of all of those albums whenever I choose to show the albums with the artist. I'm going to go over here, we'll pick album. So we go artist to album. And then the source column will be the artist ID and the reference column will be the artist ID. That's what it will be connected on. So I'm going to hit create and you can see that we now have this relationship. So if we navigate back to our API to where we're issuing queries, we now see that we have a nested object relationship here. So if I pick name of the artist and then go into artist album and choose the title and run this query, we now see that in the database, we have listed 2 albums for AC/DC, et cetera, on down. Some artists have 1, some have 2, as you can see. Now, just in case, yes, there are more than 2 AC/DC albums, but that's what we have in the database. I know that for a fact. So don't think that's not showing all the titles there. All right. So now one of the other things that we can do at this point is, let's say we want to pick a particular artist. We can add where, go in and just pick a particular one. I usually pick Metallica. We have a few albums for them. And there we go. Okay, so that shows you that we're connected to Snowflake. We've looked at an instance specifically in Snowflake, picked the tables from that instance, then issued a query and then a nested object query and added a where clause so that we can pick particular data out of that, that warehouse or data lake that's stored in. Now, one of the great features is the relationship that I just showed you, which is specifically built into Hasura. So anything that's in the database is one thing, but this is an extra layer of logic and structure that you can add to your schema to query against with your data. One of the other capabilities that we have already is like, this is, just call this my artist query. If I add the directive for cached, that instantly starts to cache this GraphQL query. Now, when you're familiar with SQL, you probably look at that and think, there's probably a little bit more going on than what the GraphQL query immediately shows you, because we have a nested thing between 2 tables here, right? So what's actually going on in the back end, if we hit analyze, we can see that there is an initiated select query, and then on down, there's another one. And as you scroll through here, you can see if there's any other queries based on what you're issuing here from the GraphQL. So even though we've only issued one GraphQL query specifically, there's actually multiple queries that have been issued against the Snowflake instance. When you add cached, it then caches that. And if there's an available copy in the cache, then it doesn't issue that directly against the Snowflake. So it can cut down on the back and forth there, help you out a fair amount when you're issuing queries and things like that against your Snowflake instance. So we've covered the basic core abilities of the connector. We are in beta right now. You can try this out yourself. All you got to do is go into that little gear button here and then go turn on the experimental features and you'll see Snowflake along with Athena and other ones. And we have query capability, aggregates, where clauses, et cetera, and we will be adding more features and capabilities here in the near future. So that is Snowflake. Go check it out.
Thank you, Adrian. That is a great preview, and I am super excited to see Snowflake come to the Hasura ecosystem, because I mean, big data is one thing and everybody loves getting it all, but like, how do you then get that into the application? How do you then do something with it? And that's like exactly like the core set that Hasura is really awesome at solving for.
Oh yeah.
And so really cool examples. So if you've got any Snowflake questions, yeah.
I was just gonna say one little tidbit extra, especially for those using Snowflake, they probably heard about Unistore, which is the new OLTP capability extension, or shouldn't call it an extension, but new feature capability that Snowflake is releasing. And as they release that and it gets out of preview, we'll also be supporting that, and extending along with that. So we're going to cover the full breadth of everything Snowflake does. It's going to be pretty awesome.
All right. So moving right along to our next presentation, we've got David Mullaney with our GA release of AlloyDB, another data source for you all. David, you ready to go?
Well, I'm going to talk about today is AlloyDB, which was just released. It came out of preview this week, announced by Google, and Hasura was a launch partner as part of that effort. So so we were a launch partner for AlloyDB, and as part of that process, this partnership ensures that we have the best integration with them, and we get feedback from them. And one of the features within AlloyDB that we identified was this ability to do both bulk and concurrent reads. So that's if you have tons of tables that you're trying to introspect when we're uploading a database, or if you're reading data from multiple tables, it's a cool feature within AlloyDB. So that's the first thing we've identified that's a performance improvement specific to AlloyDB. And that'll be released in version 2.17 of Hasura, at which point you'll see AlloyDB appear as a data source in the dropdown. And this is part of our ongoing partnership with Google and Google Cloud. We're going to be in the Google Cloud Marketplace in the coming weeks, and we already support BigQuery and SQL, Cloud SQL as well. Just for those of you who might not know what AlloyDB is, it's Google's new product that is a fully managed Postgres compatible database service. And so the reason you would choose it is over something like just their Cloud SQL solution is if you need higher availability, if you want auto scaling workloads and stuff like that, it would be a better choice for you. And so it's similar to AWS Aurora, but Google's bringing this to market later, and you can see that they have plans for enhancements, or they're kind of hinting at enhancements where this will be a database that can be used for both transactional and analytical workflows. So it's one of these databases that I've seen analysts describe in their reports as like a translytical database, which is just like a hybrid model between the OLTP and OLAP databases. Right now, it's definitely optimized for OLTP. That's like the state of play right now for it. But we're excited to see what Google plans to release for AlloyDB in the future. So like I said, we now have like the three of the superstars from the Google Cloud platform, Cloud SQL, AlloyDB, and BigQuery. And we think these are really the best of breed products that for data within the Google platform that people can leverage. And we're excited to see how users plan to use these if people start shifting from Cloud SQL to AlloyDB, and why they make that shift. But you can rest assured with Hasura that we have like a deep partnership with Google, and we'll continue to offer the best kind of support for these platforms. Yeah, let me just check the chat, see if anything came up as far as questions go. Not. So moving right along, because I know we're tight for time, Jesse. Parameterized queries. Tanmay mentioned the GraphQL data specification, and this kind of plays into that. But what are parameterized queries? Why? We just did a Hasura user group talk last night, and two people came up to me to talk about parameterized queries. And what it really is just providing the ability to leverage the database's native query language for use cases where the GraphQL engine's API doesn't support it. So we have a GraphQL schema that introspects the database and automatically creates that schema, but there's just so many things that the database can natively do that we could never make a schema that addresses all those use cases. So we want to make a kind of a better way for you to leverage any native capability of the database and then specify how it should show up in the GraphQL schema. And we are active. What I'm doing right now is I'm interviewing users and to find out if this feature, how we should build this feature, what kind of use cases. So please ping me on the community or go to this RFC that we have on our GitHub repo, and you'll see I've already responded to a few comments there because we're hoping to have a beta for this released early next year, within like January or February, to get more feedback on, and just exploring like what kind of use cases people will find this feature useful for. So stuff like tracking functions that return scalars, semantic date queries, so like complicated date math and stuff like that specific to the database. Sometimes full text search, advanced permissions and relationships is something that's come up time and time again for this feature, as well as leveraging CDW features. We mentioned Snowflake earlier. There's a lot of features within the CDWs that are continuing to evolve. They make enhancements, so it's impossible for us to say, hey, we're going to support everything in Snowflake and BigQuery natively with our GraphQL schema. We want to give you a way to leverage those features within the CDW. So nested columns in BigQuery is an example, or exotic data types in Snowflake, like objects or variants and stuff like that. And I mentioned group by here because that was a discussion that came up last night during the Hasura user group meeting, where we kind of discussed like kind of data aggregation features like group by, whether or not it should be supported natively in the GraphQL schema, or if you should leverage it using something like parameterized queries. And it was a really like good conversation between like me and like three other people about like, and someone kind of said group by should be in there, someone said it shouldn't be, and so we're trying to get as much feedback as we can as we build this feature, and please give us all your feedback as you look into it. Cool. I guess the next person I'm handing this off to is Rahul. You want to take over?
Sure. Thank you, David. Hi, everyone. Next, I'm going to talk about action improvements. There are many improvements coming in the next year. These are just the starting. And the two things I will mention today are optional query parameters and response transform on the UI. So let's start with query parameters are now optional. And why did we address this? Because defining optional query parameters for REST endpoint, if the input is empty, the query parameter will still be attempted, and that was causing error for users. And now we are making the option less strict and introducing a new syntax. That is, instead of the syntax there, you will use a question mark, then variable name. And with this, now you would be able to send optional query parameters in actions. And why is it important? Because it unblocks certain type of action use cases and just makes our REST support stronger. On the right, you can see the syntax for the optional query parameter along with documentation to check this out. A small win, but I would say great impact to our user community with this optionality on query parameters. The other action improvement we have launched recently is response transform on the UI. There was always the ability to transform responses on the server, and which you can see on the top right corner. Using the metadata API, you could do response transformation. But what was happening is that power users were asking that why can't we do it on the console? And it helps in ease of use of transforming responses. It helps in reduction of errors in configuring response transforms. And it also completes the basic console functionality for REST connectivity, with response transform now being on the console. With that, I'll provide a brief demo on how to use response transform in the UI and what is a typical use case which you would leverage this for. So let's look at a pet store API endpoint, and you can follow along with me if you want to. So this is the pet store API endpoint I'm talking about. And what this endpoint does is it gets you pets by the statuses. And as you can see that the REST server will give a response in this shape. You're asking the server about status of pets, and then you're getting a response in this shape. And now if you go to the actions creation tab on the console, we have this new option called add response transform right under request transform, which was not there before. And let's look at the find by status pet store ID, which I just mentioned. So if I scroll down in that action, as you can see, we have done the response transformation here in Kriti template form, which is mimicking this JSON shape, which the server will send. So with this, you should be able to seamlessly work with this REST endpoint out there. So let me make a quick call. We have this find by status, and I'm looking at all the available pets in the pet store, and I should be able to get that action query because of response transform. So very excited about this feature. I think now, as I mentioned before, the REST story is reaching completion. And just to give you a preview, and we'll feature this in the future community calls, is that if you go to the settings tab and under the feature flag, all of this thing here is currently manual, and we are currently working on automating all the form creation, especially from Open API specifications. And right now we have an import action from Open API in experimental/alpha phase. So please feel free to enable this and test this feature out. There will be more information shared with you in the coming months. As I mentioned, will be showcased a full-fledged demo in the upcoming community calls. So please have a look at this experimental feature. Reach out to us for any questions, feedback as you play with this. With that, I think let's go back to the next section, which is elastic connection pooling. Another, I would say, significant enhancement to the Hasura platform. What is elastic connection pooling? It is, first of all, a cloud-only feature where we have introduced a new connection pool setting called total max connections and an ability to elastically scale connection pools. And why did we do this? It was the reason why that customers were exceeding their database connections, and that was a big problem, especially around reliability, and then the added cost of maintaining the database after it has exceeded those connections. Multiple customers have reported to us about exceeding this limit, and as I mentioned, a big cloud reliability and performance issue. So under connection settings, you would see another new field called total max connections. And in the demo, we'll see how the total max connections will really help in this elastic scaling of connection pooling. And the promise is high cloud reliability with zero administration with this feature. As I mentioned, there's a new concept of connection pooling, and connection pooling is now brought to the project level. We had a max connection field before, but that was on an instance level. And let's say you had 6 connections per instance, but you had multiple instances per project. And that is where customers were facing problem of exceeding the maximum database connection which can be honored. And the customer benefit, as I said, is it will help you reduce cost with improved reliability. And with the automatic elastic scaling, you don't have to do any administration. You just need to make sure that the total max connections is as per your database SLAs. How does this differentiate in the market? I think this is an important aspect as well. Developer productivity is top of mind whenever we release and design features for you. And this only solidifies the ROI, or the total cost of ownership of using Hasura, because it would possibly eliminate the need of using external software like PG Bouncer. And so we really are excited to bring this feature out, and let us know how you're using it and if it is making your life easier. What you see here are the configuration via metadata APIs. So the total max connection here is the setting which I mentioned. So just giving you an overall update on how you can configure this feature. With this, I'm going to show this in action. And while I'm doing that, there are two questions that came up, so I'll just take them up. Such as, so does Hasura expose an open API endpoint? Yes, it does. We have restified GraphQL endpoints. So do check that out for the Hasura exposing an open API endpoint. And is Elastic Connection pooling specific to? Right now, it is only for Hasura Cloud. We are evaluating plans for Enterprise Edition. It won't be coming into Community Edition. So if you're interested, if you have a self-hosted customer, please reach out to me later and we can have a conversation on that. So I'll just talk along as this video goes along. I'm demoing the Elastic Connection pooling feature here. So as you can see, this is an earlier version of the console, so it's called Cumulative Max Connection here, but this is similar to the Total Max Connection feature we have rolled out. So this is a new field. Right now, it is, let's see, the setting right now is for max connections is 6. And then once we, and the total max connection setting is not set right now. So if we go and run this in a while, just a minute. Yes. So here we are making a query into how many instances are running. So this is that query which tells you how many connections are running, and right now it shows you number 13. So this 13 is coming because you have 6 max connections per instance, and so you had 2 instances here running. One is for this query, so 6 plus 6, 12 plus 1, 13. That is how the max connection setting is working right now. And just imagine if you had like 10 instances, this would be 60. And there you have your database is now overloaded. So now if we go back and as you see, the instances were 2, we go and edit and remove the max connection setting and actually put it in the cumulative max connection. So if we remove it from there and make it to cumulative max connection, now you could expect the connections to be 7, 6 plus 1 for this query. So this is the Elastic Connection pooling in action. Would have greatly improved reliability, as I mentioned. With that, yes, I'm here again. This is the last feature for me, which is the dynamic database connection feature set. And why it says feedback, because we are rolling out an alpha program right now, and we are requesting feedback, comments, and inviting you to try this feature out in alpha state. So what is dynamic database connection? It is on a very high level, the ability to dynamically route GraphQL queries. Some of the main use cases it can help you with are routing to specific nodes based on your identity access management roles. It could be used to route to a specific tenant based on session variable. And also a very important use case around no stale read. So Hasura supports the notion of read replicas, but for instance, you need a query which you don't want it to go to a read replica. In that case, you could use this feature to route certain queries to the primary node. But these are not only there are many use cases out there which this feature can cater to. And the reason why that is possible is because the solution is CRITI-based connection template. So you can go wild with this feature, if I may say, and that's why we are rolling it out in an alpha beta kind of manner so that we are able to contain the surface area. And we have introduced a new notion of connection sets, currently supported only via API. And as I mentioned, and the alpha program is underway, we are already in conversation with one customer, and we are inviting other customers to collaborate with us on this feature. So kindly fill this form here to get access to the custom build and also have one-on-one meetings with the product engineering team on this feature itself. And when you access that link, you'll also will get a link to the public RFC. So feel free to read through that detailed RFC and ask questions or comment on that. That would be very helpful as we move into the beta phase. And I would say beta is somewhere estimated in around January, February timeframe. With that, let me show this in action and then hand it over to Gordon. So what I've done here, I have a Docker compose file, which has 2 DBs, one primary DB and then other DB URL. And if I look at the metadata of what is happening behind the scene, this is the new feature which we have launched, which is this connection template, which helps you dynamically resolve the query at runtime. So let's see, and that's what I mentioned, this feature, you can go wild with it because it's pretty template based, based on the logic you can insert here. So let's see what logic we have inserted. We have said that if request session X Hasura role is user, then use primary, else use the other DB URL. This name database is a grouping where you could put the other DB URL. And this is that name database setting, and which once applied, it would fetch the data from the other DB URL. So just let me show this in action. So right now, if we go back to, so we are saying if it is user, go to primary, otherwise go to the other one. So let's say I go and change the Hasura role to user and I run this query. The data is coming as IDs 1, 2, 3. And the moment I change it to admin, it will go to the other DB URL and the IDs have changed to 100, 200, 300. So pretty simple in terms of experiencing this on the console, but as you might know, there's a lot of complication behind the scene, and the power of this feature is something we are very excited about, and we're looking forward for you to kind of leverage this new feature set. And please reach out to us and be part of the alpha program. That would be something we would really like. So with that, thank you so much for your attention today. And
again, these slides will be shared with everybody who's come today to the call. So if you're looking for links or things that were shared, you'll have access to all the links as well one more time. So if you'll get some of those RFC links and things like that in your email. So that brings us to our community contributor. Gordon, is great to have you back for another one of these, and it's a lot of fun. Gordon's going to give us the streaming subscriptions, like in real life, how it's made a massive impact for their business. And yeah, we're super excited to have you here. And because of time, we're going to jump right into it.
Quick bit of background on myself. My name's Gordon. I'm the technical co-founder of a company called Lineup Ninja. What we do is help people plan conferences and exhibitions that have large speaker programs. I shall show you. This is our main dashboard for planning an event. So as you can imagine, all the things on the board are sessions that need to be planned or are planned in different stages in an event. We have events running up to 500 sessions and 1,000 speakers, that kind of thing. Our USP here is one of our many USPs is the little marks you see down the side of each of the sessions here. What we're trying to do is help the event manager pull together an agenda that works very as efficiently as possible. Green means everything's okay for that session. Red means there's a problem with it being scheduled at that time. For example, for this one here, the user just hovers over it. They can see what problems they have. Here, the speaker's not available, and in this particular instance, it's in an inappropriate location. So we can just drag it around. As soon as the user starts to drag it, we highlight on the board where an appropriate time for that session to go is. And okay, it might fit here. If it can't go there, it'll tell them why, all that good stuff. We put it there, it updates, and the user can carry on with their day. The orange bits mean the speaker needs to know their new time, and we have some stuff that will confirm that time with the speaker. That's our kind of core part of the product. We've got a whole kind of flow for calls for speakers and like speaker data acquisition, and then a whole other side of the product for publishing this data out to numerous integrations and digital signage and speaker advocacy apps, all that good stuff. So that's the whistle-stop product pitch. Now, where it gets interesting from a subscriptions point of view is we're just showing in that board there. All that data the user's looking at is live, and any changes made by any user in their team or by a speaker updates automatically in their screen as soon as that change is made. For example, if we've got two users here, and I just move that session back where it was before, you'll see that just updates for any other connected user. And that goes for all data in this platform. So if your speaker logs in and changes their name, it will just update. If they want to request a different time, that'll be highlighted for the event manager to see that. We have a principle that the user should never have to refresh the page or navigate away and come back to see the correct data, because we're really focused on ensuring that teams can work coherently together without risk of them looking at out-of-date data. Because the real challenge in our industry is people working with 1,000 versions of Excel sheets and all this kind of thing. So trying to put an end to that and be a bit more like Google Docs when it comes to event content management. Now, I'm just going to share with you all our kind of story as to how we've come about this and making this work really super swish on Hasura. Because we've been going quite a while now, and we actually started out on Firebase real-time database. Which is how we've come up with all this kind of somewhat crazy idea of subscribe to all the data. When we started, we chose Ember for the front end, which we still use and still like a lot. It's really come on a long way as a framework. I would recommend everybody takes another look at it if you've used it in the past. But at the time, we used an interface called Ember Fire, which was a plugin for Ember Data. That's basically an ORM. So that provides models for all of the objects. So if like a session, a speaker, a track, a location, all of those are individual records. So what we do is the user connects, and then we effectively, in real-time database, we subscribe to all of the user's sessions. So, there could be 1,000 of these and like 500 speakers, that kind of thing. And you would think that would never work, but actually it worked fine on real-time database. It would not work so well in Cloud Firestore, but at the time it worked fine. Because it's all real-time, as the user makes an update on the left-hand side, that gets down through Ember, persisted into their data store, written into real-time database, comes up the other side, and all the users can see it. Okay, that was all great, worked well. And then we came to a screeching halt as we kind of expanded the product. The most fundamental problem that was that at the time, and I believe this is still true, although I could well be wrong, but Firebase is not available in China, Saudi Arabia, and other countries where Google is prohibited for doing business, which is a real problem for our clients, end users, because their events are often global and they need to have speakers from all over the world. We were also running up against a need to be able to do more complex queries than we could manage with a real-time database. So we started on a journey of looking for alternatives. This was around the time Hasura was about alpha 30 something. So we came across Hasura. It's got a very similar security model, and from a query model, the GraphQL was a reasonably decent fit for real-time database. So we thought we could do the migration relatively straightforwardly. From a query point of view and a mutation point of view, it was great. It was simple. From a how the hell do we maintain this real-time data for everything? It's been on a journey to where we are today, I think it's fair to say. We started with an incredibly naive fix because I was under a lot of pressure to deliver something for a customer's go live date that was fixed in stone. So how we started was, for all of the records the user was interested in, we would poll the database to see what the most recent updated date was for any of the records they were interested in. So the query looked a bit like this. So query for the sessions where the ID is in all of the sessions that user's currently looking at or has access to in that event, and the updated date. Do that for session speakers, locations, tracks, blah, 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 all these resource types. It was kind of crazy, but it worked. And when you're a small business, you know, working is the first thing that needs to happen. You know, make it work, make it fast, make it good, etc. It worked, but it was really heavy load on the client, making these large polls, and we were polling every second. So 86,000 times a day, and these polls are quite large. So it was fine, just about, for a user with one tab, but as soon as they opened another tab, all their fans would turn on. So that was fine for a while. Pandemic happened, so we weren't exactly overloaded with new users during the pandemic, as you might imagine. But that all came to an end, fortunately, and we started scaling again. So we're like, well, we needed to address how we were fetching the data to cut down on front-end load and back-end load. And at this point, knowing that streaming subscriptions were coming, I decided to refactor it to this concept initially, which was to have a separate notify table. So say when the user writes to a session or a speaker, a Postgres trigger fires and writes into just one table that's saying this record has changed. And the record that gets written into that table has like a scope. So users that belong in this team, or they're looking at this event, or they are this user, might need to know this record's changed. And then the idea is that the user can then say, I'm interested about change in these types of records. So I'm interested in changes for this event. I'm interested in changes for this team. And they receive all changes about that team. They might not need to know about that particular record, but it doesn't really matter, because they can receive that and throw it away. That's much quicker than them saying, I'm specifically interested in this big list of data. So we migrated to this. It worked fine, but it was still load on the client. They're still polling all the time. And we're really keen to try out streaming subscriptions, which enabled us to basically really simply change that query to a streaming subscription. Finally moving away from polling after all this time and reducing the client load to basically nil, because once it's creating the subscription, it's just sat there waiting for data from the back end. We were working to this and worked closely with Hasura to identify the best way to manage a cursor in this subscription table, because some of the writes we make into this table might be potentially like 1,000 records might get written into this table in one go. And we needed to make sure that this cursor was atomically increasing. I think Jesse has a blog post covering this in more detail, but in summary, we needed to take a serial and use that within an advisory lock. But for that trigger that's taking that serial and creating that lock, to do that in a initially deferred trigger, so that it didn't hold the lock over that serial for too long. So we were able to just increment this serial. So I'll just quickly show you this in action. Here's the two views we had earlier. So here's my connected subscription. So if I come here and let's say I move this session here, you'll see the data updates, the ID of the record changed, and the serial. So this is all the user needs to subscribe to is this data. The data comes through, the client sees the updated ID and goes, oh, okay, that's updated. It can check whether it needs to know about that. And if it does, it just queries Hasura for the whole data object that it needs. So, you know, this user could be subscribed to thousands of records and they just receive a really small notification when they change. So it works super well. I'm very happy with it. And as ever, very thankful for Hasura and their awesome support they've given me over the years to come up with this. So yeah, that's me. Thanks very much. Oh,
Thank you, Gordon.
I'm El Gordino on Discord if anyone wants to hit me up.
And he is a wealth of information too. So definitely hit him up because he'll definitely have some good information for you if you're stuck on something. Really, really appreciate that update. And just a quick note as well on that note you mentioned about how then the client just sits there and waits for information. The fact that with streaming subscriptions, you're able to allow the client to sort of configure its terms for what it's looking for real-time data and have relations on that, like that's fantastic for building. So really, really great stuff. Thanks again for giving us the rundown on that. And I believe we're planning a webinar for more detail about the architectural pattern, migrating from Firebase to Hasura as well. It's going to be in there. There's some really great stuff. So that brings us to the end. We have 2 minutes to get up to our community updates here. So we're going to move right along. Basically, we have our swag winners. So congratulations to Sahel Gulam for getting our first pack of swag, and to Darren Jennings, who gets the other pack as well. So there's a lot of neat little goodies in there, something to keep you warm on your feet, and something to keep your coffee or tea warm, whatever's your cup of tea. So congratulations. We'll be sending you a form to fill out, and you'll get the information to get that. The Enterprise GraphQL Conference videos are live, so feel free to catch this link, and you'll be able to go ahead and watch some really great content about GraphQL in the enterprise. So if you're building like really large scale applications or having a need for GraphQL in a really complex environment, high regulation, widely federated, whatever it might be, this is going to be a lot of great content to have a look at. It's not just Hasura content, but I mean, Hasura content's the best content. So maybe I'm a little bit biased, but that's just me. Next community call, not happening this year. We're going to see you in the new year with the final community call of the year. So definitely sign up for that. We'll love to see you there on January 26th. And there was a couple of questions about Discord. We have a Discord, so do definitely stop by. We have that actively monitored. You're going to be able to get questions or routed to the right place if you need help. And if you have any feedback on this call or just the calls in general, we'd love to hear it. We want to make sure that Hasura and our community events are an inclusive place for everybody. So we'd love to hear your feedback. What did you like? What did you not like? Should I lose the hat? Probably will for the January call. But that is going to take us to the hour on the dot. And so from everybody at Hasura, we really appreciate you joining us this last year. It's been a really wild journey as the product team has exploded, as the content has exploded, really great stuff. And we look forward to seeing you all next year, building great products and working with you. So have a great one, everybody, and we will see you next year.